press the bell icon on the YouTube app and never miss another update.
Hello students. So today let us continue with the exercise 12.3. Okay. So we have two problems here. See the first one, that is in your textbook, it is 13th one. Okay. So I am going to read the question. In the figure, a square OABC is inscribed in a quadrant OPBQ. If OA is equal to 20 centimeter, find the area of the shaded region. Pi is equal to 3.14. Okay. So in this figure, a square OABC is a square which is inscribed in a quadrant OPBQ. See here, OPBQ is a quadrant and square is inscribed inside the quadrant. And what is given here? They have given OA is 20 centimeter. So OA they have given 20 centimeter. So except this data, we don't have any other data. Okay. So how to find out the area of the shaded region? Here you have to find out the area of the shaded region here. So first let us write area of the shaded region is equal to, so you all know by now, area of the quadrant minus area of this square. So area of the quadrant, which is that quadrant OPBQ, minus area of the square OABC. This is the square. Okay. So this will be the first statement for you. Now to find out the area of the quadrant, what is necessary? You should think. To find out the area of the quadrant, we need, one thing is theta, the second one is radius, isn't it? So these two things. Now since they have told it is a square, so this will be 90 degree, no doubt, correct? Next, so how to calculate the radius of the quadrant? Say here the radius is not given. This is OA is not a radius. OA is the side of the square. So OP is the radius. Okay. OP is the radius. Or if I draw a line here, if I join OB, then OB will be the radius. Please observe, it's very, very important. If you know this, the sum is very easy. Okay. See, OB is the radius of a circle. See here, OB, say, just imagine OB, if it coincide with OQ, and if OB is coincide with OP, then OB is equal to OP is equal to OQ, means that is nothing but the radius of a quadrant. Is it clear? So our duty is to find out OB. So it is easy to find out OB by using Pythagoras theorem. See, because this is a square and definitely we know this is 90 degree, everywhere it is 90 degree, all the angles of a square is 90 degree. Therefore, so by using Pythagoras theorem, we know OA is equal to 20 centimeter, OB is also 20 centimeter, correct? So by using that, we can find out OB, that is by using Pythagoras theorem. So to find out, let us join, you have to write this and you have to show that in the diagram also. Let us join OB and OB is the radius of a quadrant, OPBQ, correct? OB is the radius of a quadrant, OPBQ, correct? Now, so in triangle, let us find out in triangle OAB, okay, by using Pythagoras theorem, you can write that OB square is equal to OA square plus AB square, correct? By using Pythagoras theorem, you can mention that theorem. Okay. Now, OB square is how much? We don't know. OA square is how much? 20 square plus 20 square. Okay, 20 square plus 20 square. So, here you will get 20 into 2400 plus 400. I hope you understood this. So, why we have to join this OB? It's a diagonal of a square. So, and also it is a radius of a quadrant. So, now let us find out the diagonal now. Now, OB is equal to, so this actually we can write it as 400 plus 400 is equal to 800. So, but you can write like this also, 2 into 400, yes or no? Because I am using square root, I am doing this method. Now, 2, what is the square root of 400? You all know it is 20 root 2 centimeter. Okay, now OB is the radius and it is 20 root 2. So, it is the radius R of a quadrant. Now, once you know this, that is 20 root 2, I think it is easy for you to do the other things there, okay. So, shall I rub this and we shall continue with that. So, this is extra steps you have to do and you have to find out OB. Now, once OB is found out, then you can apply the formula over there. Now, area of the quadrant. So, let us find out the area of the quadrant. As you all know, formula theta by 360 pi r square, also you can do or I told you pi r square, that is the circle, area of the circle divided by 4, okay, however you feel you can do it. So, if you are using this, you have to put 90 degree there. 90 by 360 is nothing but again 1/4 pi r square, correct? I hope you understood this. So, I will do this only directly. So, pi, so they have not told you to use 22 by, so sorry, they have not told to use, yes, we have to use 3.14. So, you have to use 3.14. So, here pi 3.14 into r square, that is 20 root 2 into 20 root 2 by 4. Now, 4 ones are 4 5s are, okay. Now, just do this into 5 into 20 root 2. Now, you can calculate root 2 into root 2. So, root 2 into root 2 is into 2. I hope you understood this. See, 5 into 20 into root 2 into root 2, root 4 into 2, okay. Now, let us find out this. 3.14. So here 100. So 3.14 into 5 to the 10, 100 into 2. So 100 you all know, 3140 point here into 2. So this will be 4 2s are 8, 2 1s are 2, 3 2s are 6. 6 centimeter square. Okay. 628 centimeter square. So this is what? This is the area of the quadrant. Area of the quadrant. Now let us find out the area of the square over there. Okay. So let us write this here, 628, because I am going to rub the board now. Now, okay, area of the square, OABC. So you all know 20 into 20, side into side, correct formula? Okay, now centimeter square, 400 centimeter square. Now what is the next step here? Area of the shaded region. Area of the shaded region is equal to area of the quadrant. Just now I got 628 minus 400. See, just now I told you to find out the area of the shaded region, area of the quadrant minus area of this square. So, what is the answer? 8 to 2, 228 centimeter square. 228 centimeter square. Okay. So, this is the answer for this one, 228, that is this part, that is shaded part is 228 centimeter square. Okay. Now, let us move on to the next one. Next one is quite easy. It's quite easy also and interesting also. See here, just observe the figure. I am going to read the question for you now. 14th one, AB and CD are respectively the arcs of two concentric circles of radii 21 centimeter and 7 centimeter and the center O. If angle AOB is equal to 30 degree, find the area of the shaded region. See, now just observe here, the diagram is there for you. Now, according to the question, this AB and CD are the two arcs. I hope you all know the meaning of arcs. See, in the circle, it is a part of a circle, this part of a circle. See this, think it is, and this is the center, and if I draw this part, see this is AB, it is a part of a circle arc. Okay. Now, this AB is a part of a circle and it is an arc. CD also is an arc, but the center is same, that is concentric circles. I hope you know the meaning of concentric circles. See, two circles which are drawn with the same center. So, that is called concentric circle. Just think, see this is nothing but, I will use, see it is nothing but it is a part of a circle. See this part is elaborated and written like this, correct? So, two concentric circles and these are the two arcs of a concentric circles. See only this much, this part. See, they have taken only this part. Just imagine, this part they have taken. Okay. But in that also you should find out only this area. Means, see if it is like this, You have to find out only this part, shaded region. Okay. So, this is the part of this two concentric circles. Okay. Now, here the concentric circles, they have given two radii. See, one is 7 centimeter. See, smaller one is, it is having the radius 7 centimeter and the bigger one is 21 centimeter. Okay. So, now how to find out then this one? See, it is very simple, easy. See here, you can find out the area of the sector, full sector minus area of the smaller sector, isn't it? Is it correct? Area of the bigger sector, if I use the word bigger sector, you can use, or you can name this area of OAB, area of the sector OAB minus area of the sector OCD. See, if you subtract this, this shaded region will remain. Okay, it is quite easy. So, let us try to do this sum. Area of the shaded region is equal to area of the sector, which is the sector, we will name that sector OAB minus area of the sector OCD. Okay, area of the sector OAB minus area of the sector OCD. Now, so we can at a time we can do this sum, or if you want to do it separately also you can do. For this I am going to do at a time because some things are common here, so I want to use it. See, when we say the sector, you all know theta means sector angle is very important, and here the sector angle is 30, which is common for both the sectors. I hope you understood. See, 30 degrees is common for both the sectors. Okay. So, but only thing is radius is different. Radius of the smaller sector is 7 centimeter and the bigger sector is 21 centimeter. So, I will try to do at a time. So, area of the sector OAB. So, you all know. So, we will write the formula area of the sector. Area of the sector. Theta by 360 pi r square. Okay. Now, area of the shaded region, you have already done this type of sum previously. Area of the sector OAB, so theta by 360. So, I will write, once I have written the formula, no need to write again the formula, 30 by 360. Here they have not told us to use 3.14. So, we can use 22 by 7 into R. So, bigger sector OAB. So, OAB means bigger sector. The radius is 21 into 21 minus, okay, I hope you understood this, minus 30 by 360 to 7, because the radius of the smaller sector is 7 centimeter. Okay. Now, so to make our calculation easy, what shall we do? We will take 30 by 360 outside and 22 by 7 also. So, it is common for both. So, what remains? 21 square minus 7 square. To make the calculation simpler, so I have used this method. Okay. So, however you want, you can use. You can simplify here itself, simplify here, then subtract. Okay, that is also correct. Now, I will do this 0, 3 ones are. Okay, now 11 by 6 into 7, and here I will use a square minus b square, okay, a square minus b square. So a plus b into a minus b. So here 11 by 6 into 7 into, so here 28 into subtract 7, so it is 14, correct. Now 6 here we can cancel, 7 ones are 7 2s are 14, 6 it won't be cancelled, 6 5s are 36, okay. Now 2 ones are 2 3s are 6, okay. Now see, we are having this much, so 11 into 28, okay, we shall find out how much. So I will do it here, 11 into 28, see 11 into 28 divided by 3, okay. So 8 ones are 8, 8 ones are 8, 2 ones are 2, 10, 1, 308 divided by 3. So you can keep it as it is, 308 divided by 3 centimeter square. So this is the answer. So area of the shaded region is 308 divided by 3 centimeter square. So you can put it in the decimal form also, or you can keep as it is, okay. 308 divided by 3 centimeter square. I hope you understood this problem. So this is very simple problem. So I have covered 2 problem in this class. See, this one I told you, you have to find out the radius, okay, to find out the radius. So by using the data given is this sides of the squares, except that we do not have any other data. So by using that you have to find out the diagonal, okay. The diagonal is nothing but the radius of a quadrant, okay. So only this sum is very simple, and we can expect different type of diagrams for you in the exams. So please practice, be thorough with the concept. So you can attempt any type of problems in this. So once you know the concept, it is very easy this, okay. So you may get a different type of diagram in this chapter. So you should just go through the examples also, okay. So in the next class I am going to continue the last 2 problems which are still more interesting, okay. Thank you very much.